I will leave a link in the description for you guys to see. So you can see here, this is in German. So here is a video of the cluster working using these codes. As you scroll down, so this is the circuit diagram on how to make all the necessary wirings to get the setup and running. These are the different games that it's supported in. So you can probably open this in Chrome or some browser and get this translated. I'm going to translate this. So this is now in English, so you can see. So this is the Arduino sketch that needs to upload it to the Arduino. This is the plugin file. This plugin file needs to be copied into the root directory of the SimHub installation, where you have installed it into the folder. And these are the ncalc properties that needs to be copied in, which I'll be showing you at the later part of the video. These are the following materials that you need for this setup. You need an E46 cluster. So I'm using an E46 low-line cluster in this particular video. A low-line cluster would be the one that has this check control light. There is another variant, it's called the highline model. It would be a bit different. It would not have this check control light. Instead it would be mostly text, and it would be a little more different. I haven't tested on that model, so we cannot confirm if it would work on it or not. Then you need an Arduino Mega, a canvas shield. I would suggest that you get one from Seed Studio or one from Spark Fun. I'm using one from Seed Studio, the version 2. I had tried a Chinese model also, but I have had some issues with it, so it's up to you. In my case, I haven't used a servo. So the servo here is in case you want to get the fuel gauge working. The fuel gauge will not work in this, so to get it to work, you need to use a servo if you do plan to use. In my case, I haven't, and this would require the modification of the cluster itself. Physically, you need to remove the stepper motor that's inside the cluster and then attach this servo in there. But in this case, I will not be doing it. I'll just leave it as such, and I do not plan to use the fuel gauge. You will need 3 transistors. So this is an NPN transistor. In my case, this doesn't specifically need to be this particular transistor. You can use other NPN transistors also. In my case, I have used BC547. It's almost similar to this. The only difference is the collector current capacity is much lower in the transistor which I am using, which is around only 100 milliamps. But this particular PN 222-2A model, it can go up to 850 milliamps. But honestly, it doesn't really matter in this case, since we're just using it to emulate the K-bus signal. So it's not really relevant. You can use any NPN transistor. The simple cheap ones, like I mentioned, the BC547 will be fine. The next one is these resistors. So you'll need these 4 resistors. These 2 resistors will be used mainly to adjust the temperature. But yeah. Then you will need a perforated circuit board. You would need an Arduino relay channel with at least 3 relays, a couple of male to female jumper wires, and some soldering experience. That's basically about this. Also, to get a pinout of the cluster, you can go to this particular link. By clicking this, it will take you to this website. There's detailed information about all the pinouts of the cluster. So you have all the information here. So in front of me, I have the cluster. So you can see this is a low line cluster with check control light. This is the particular model that I have. You can actually ignore the switch. I added this mainly to access the functions, the onboard computer on the cluster. This is not necessary for the simulation at all, so you can just ignore this. You can see I have added some old film canisters. These are just to give the cluster some support when it's on the sitting on the table. So we have two connectors here. So it's usually numbered from 1 to 13. So this goes from 1 to 3 like that up to 13, and this would be from 14 to 26. Similarly on this side it would be from 1 to 9, and this would be from 10 to 8, pin number 18. And you would also need the Arduino CAN bus shield. This is 2.0, and this one would be an Arduino Mega. So you would need to connect this on, place this, install it exactly onto the Arduino shield. So you need to install the Arduino Mega, the shield onto the Mega. This is where the two CAN bus lines would be coming in. The serial connection would be over here in number 16. And this would be the K-bus circuit. So you can see it in all. These are the transistors, and this is the circuit that needs to be soldered depending on the circuit diagram. This is the K-bus circuit. I have soldered it according to the circuit diagram. So you would need to solder and make these connections. So in this case, this line would be from the speedometer. So this would be connected to the cluster where the speedometer is. This would be also going to the cluster. This would be K-bus line. This would go to the 12-volt power supply. These two would be connected to the Arduino's ground and 5-volt supply. As you can see here, the ground and 5-volt. The black is the ground, and the brown would be to the 5-volt, and the gray color wire would go to the serial line. That would be to pin number 16, and the white color wire would go to Arduino's pin number 46 for emulating the speed. And so we'll make the connections to the cluster now. For me connecting all the jumper wires, I've used this terminal strip. This would make the connections much easier. So I'll be using half of this circuit for the negative, minus, and this would be for the 12-volt. So from the K-bus circuit, so this is for the K-bus. So this will go to pin number 14. So this will be connected to pin number 14. This will go over here, pin number 14. And for speed, this would be to pin number 19, which would be connected here by pin number 19. So the next thing that I'm going to connect is the CAN bus lines. So pin number 9 would be CAN high, and pin 10 would be CAN low. So red would be for CAN high, and the brown would be for CAN low. I'd like to point out something. So previously I made a mistake. So the K bus would actually go to pin number 19. It should be over here, not over here. So I've connected the CAN lines, and this would go over into the CAN connections. So the high would go to the CAN high over here. Let me just focus. So the CAN high would be to the red connection, that is pin number 9, and CAN low would go to pin number 10 on the cluster, on the black connector over here. So this would be the serial connection from the K bus circuit. So that would go to pin number 16 K, and this is for the speedometer. This would go to Arduino pin number 46. The remaining 3 wires are for the backlight, cluster backlight, the ABS, and the parking brake. This is also from the K bus circuit. So the brown color is for the plus 5 volt and the black color is for the ground. So I'm just going to connect it over here, ground and 5 volt. That goes over here. So that's also connected. For the Arduino relay, so as per the circuit diagram, Arduino number, the pin number 42 is assigned for the backlight. So with the cluster backlight, the ABS will be in number 44 and number 40 is parking brakes. So all these are wired, these 3 connections, and it's connected over here. So you can connect in any of the orders, it doesn't matter. And then these, in my case, I've connected it to 1, 2, 3. So it would be 1, 2, and 3 over here. Number 4, I'm not utilizing it here. So you will need to connect the ground, and for the VCC, this will need to be plus 5 volts. So you need a 5 volt supply to trigger this. So I would recommend you use, I'm using an ATX supply, so I'm using the 5 volt from the ATX power supply itself to power this on, using a pair of jumper wires like this. So after connecting these corresponding connections over here, so here we have connected Arduino pin number 42 for backlight to, let's say you have connected to IN1, the first relay. It means, so as per the circuit diagram, the backlight needs to be enabled by connecting it to the 12 volts. So you would take one of the central pin and connect this to the 12 volt over here, and the other side of this connection would go to the cluster's pin number 7, that is for the backlight of the cluster. Similarly, for parking brakes, it would be pin number 23 over here, and the ABS light would be pin number 22. So you need to take those connections and connect it over here. So what I've done here is I've taken all the common connections, the one in the center, from all the 3, and I've connected it to the corresponding terminals. So for the ABS and the parking, it needs to be grounded to be turned off. So you need to see which pin you have assigned and the corresponding relay. You take the 2 common wires, that's the central connector, and connect it to the negative terminal. So here I have assigned the negative, and for the backlight, the common connection is connected to the positive terminal. Now the remaining wires for each of them, this is for the backlight, this would go to pin number 7. I'll be connecting it over here. And for the ABS and parking brake, it would be pin number 22 and 23. So I'll be making those connections here, and I'll come back. So after making those connections, the next thing you need to do is pin number, that is pin number 4, 5 and 6 needs to be connected to the 12 volt power supply. So the next thing that needs to be connected is for the ground. That would be pin number 1, pin number 20, 24 and 26. In the circuit diagram, pin number 4 over here is also labeled. That is to actually turn off the washer fluid lamp. If you do not connect it also, no problem, but it's just that the washer fluid indicator lamp would be lit up on the dashboard. Now for making the connections from the Arduino to the relay channel, what you need to do is, like as seen the circuit diagram, so you need to make the corresponding pins for the cluster, backlight, the ABS and the parking brakes. You can connect it to the relay channel's data pins, and for the corresponding one, let's say for here the first one is for the backlight cluster. So the backlight cluster needs to be connected to the positive terminal to be enabled. So I have connected a 12 volt supply to the common and the other side to the cluster's backlight. So this would enable. And similarly, the central terminals you can connect for the other two. The ABS and the parking brake needs to be grounded. So I've connected the central connections to the negative terminal of the power supply, the other ones to the for the pins for the parking light and the ABS. So to get started, we need to first download the Arduino file given in the description. We need to download the zip file and extract it. It would look something like this, the folder. We need to open the folder, make sure all the files are with the Arduino file itself. So install the Arduino IDE and open it. Next, you need to connect your Arduino to your computer via the cable. Then go to tools, check, make sure the board Arduino Mega is selected, the correct processor and the port. So once it's detected, then you need to make sure that the Seed Studios library is installed for the CAN bus. But for this particular code, you need to select an older version of the Seed CAN library. The latest one will not work. It seems to have some issues. Once you add that, you need to upload the file to your Arduino. So it's currently uploading the code to the Arduino. So it's complete right now. And once you close it, the next thing is you open the SimHub. Okay, so now you need to, I'm going to set up with American Truck Simulator. So you need to go to launcher. It should be the 32-bit version, that is into 86. So you need to go to the game directory where it's installed, go into the game folder. You need to go inside bin, then to the into 86, and select the launcher. That's it. Next thing is you need to install the plugin to get the data from the game to the simulator. For that, you need to copy the plugins folder for the 86, then go into the game where the folder has been, and inside here you need to paste the plugins folder, and that's it. So here I have already pasted it, so I'm not doing it again. Okay. Next is you need to plug with the Arduino connected. Go to Arduino, My Hardware. You need to select multiple Arduinos. In multiple Arduinos, you should see this option where it says the multiple Arduino settings. So once your Arduino is detected, it would appear it says connected, and so it's in COM4, it's detected and it says it's connected. So now you need to set the serial rate to 230,000 something, yeah, 230,400. Next, you need to go to Neuros project website. This website is in German, so you can just translate. So you need to copy this entire encalc properties. Copy this, and you need to go to custom protocol, computed value, and you need to paste it here. Mine is already pasted, so it's done. And once you paste it, click OK and click apply changes. And yep, the next thing is need to go to settings, go to plugins, then you need to download the share data plugin. Once this is downloaded, I have already downloaded in my case, so I'm not downloading, so it would be this file. So you need to copy this particular plugin into the root directory or the installation directory of SimHub. So you need to go here, file locations, and you need to paste it into the root directory. Once it's copied, once you launch SimHub, it would ask a new plugin is detected. You say yes, and once you scroll down to the plugins, you should see it somewhere here. Yes, and there is Neuro plugin. You need to enable this. And just to clarify this, I will try to copy it and show it to you guys how it's done. So I'm just copying it over here, placing it, and then I'm launching it. In my case, it's already done, so you'll not see the message, but when you do it the first time, it would ask a new plugin has been detected. So this is already done. Next, we need to go to Dash Studio. This step is critical, or else the cluster will not work. Like, it would be very intermittent. So you need to open this dash, any dash that's present here. It can be any random one. I just chose this one, then minimize it and keep it down there. Then you need to launch your game, and now it should hopefully work. Yes.